Hey, welcome to ashatech.com, your engineering sciences channel. In this discussion, we have got logarithms and indices. So the guiding question says, part A, if 2 log 8 log n base 8 is equal to p, log 2n base 2 is equal to 2, and 2 minus p is equal to 4, find n. Then also solve the equation 2x 2 to power x squared is equal to 16 to power x minus 1. Let us look at the solution to this particular problem. Now we have the two unknowns p and q. 2 log n base 8 is equal to p, 2 log 2n base 2 is equal to 2. Then 2 minus p is equal to 4. I just substitute whatever I have for 2 and p in this expression. I equate it to 4 and I form an equation that is in logarithms. So that means I will have log 2n base 2 minus 2 log n base 8 is equal to 4. That means when I look at this expression, the lowest base is 2 and the highest is 8. So it is always good for you to proceed and solve this problem. You should have the same bases. If you don't have the same bases, then it is a little bit complicated. So you have to change to a base, and it is always advisable to change everything to a lower base. So now if we look at the 2 log n base 8, we need to change it to something in base 2. Now 2 log n base 8 is equal to log n squared base 8. If we are to use laws of logarithms, then this figure that is always here, the coefficient of the log can always come out this side. So when it comes this side, it becomes a power to whichever figure is here, then maintaining the base as a constant. So let us assume that log n squared base 8 is equal to y. If it is equal to y, then we can look for a way of changing the base. So n squared is therefore equal to 8 to power y. Because if we have n log x to base b equaling to z, then this expression can also be changed to x to power n equal to b to power z, whereby b is the base and n is the figure that was the coefficient of the logarithm of this number. Therefore, if we apply the same technique, the same rule, then we will have n squared is equal to 8 to power y. If I take log to base 2 both sides, it means I have log n squared base 2 equal to log 8 to power y base 2. That means I can bring the y here, which will equal to y log 8 base 2. But if I look at the base 2 and I look at 8, it means I can produce this 8 out of a figure, figures of 2, 2, 2. So if I want to make 8 out of figures of 2, 2, it means I can have 2 times 2, 2 times 2 times 2. This is equal to 8. And this can also equal to 2 to power 3. So I can say it is y log 2 to power 3 base 2. What does this mean? It means I'm looking for an expression here that can reduce to 1, because if I continue and use laws of logarithms, it means I will have the 3 coming this way, so that it becomes 3y, and this remains log 2 base 2, which reduces to 1. So if I come here, I mean I will have log n squared base 2 equal to 3y log 2 base 2. So I've said this log 2 base 2 can reduce to 1, so that I remain with y, which is equal to log n squared base 2, and everything out of 3, because I've made y the subject of the formula. So if I make y the subject of the formula, then it means I can bring it back in the position, because remember I had called log n squared base y to equal to y. So the expression, since it has reduced to log n squared base 2 out of 3, remember the base has changed now to 2, then I'm able to comfortably proceed because I have the similar bases. it means when I proceed here, log 2n base 2, remember it is also the same as having log 2 base 2 plus log n base 2, because I can still combine this by multiplying the powers here. The powers is 2 and n. So if I combine this, come back to this, it means I'll have log 2 times n base 2. So if I maintain that, it means I can subtract minus 2 log n base 2, everything out of 3, and this is equal to 4. When I look at this equation, it means log n base 2 is an unknown that I cannot proceed with, so I can let it to be another unknown, which is, for example, x. Log 2 base 2 is equal to 1, as we have noted according to laws of logarithms. Then this is x minus 2. This log n base 2 is also x, so I can solve for x so that I'm able to get the value of x, which is equal to 9. So if x is equal to 9, it means log n base 2 is equal to x, and it is equal to 9. Therefore, using the laws of logarithms, n is equal to 2 to power x, and remember x is equal to 9, therefore n is equal to 2 to power 9, and which is equal to 5 total. So let us proceed. We have already now finalized with part A of this question. Let us proceed. If you check, automatically the left hand side should equal to the right hand side. Now let us look at part B of this question. 2 to power x squared is equal to 16, x minus 1. Now when I look at this, I have powers, I have indices. So now 2 to power x squared is equal to, remember this is 16. Can I make 16 out of 2 to power something? Yeah, because I always hustle to make sure that I have the same base here and the same base this side. So if I am to have the same base, it should come to 2. So what value can I power 2 so that it comes back to 16? It is 4. So 2 to power 4, remember it has to multiply into the powers that were here. So I create a bracket x minus 1. So 2 to power x squared is equal to 2 to power 4x minus 4. It means since the bases are the same, the power is also the same. So that's what that's the principle I'm using here. So that I have x squared equal to 4x minus 4, and this becomes a quadratic equation in the form of ax squared plus bx plus c is equal to 0, whereby I have the sum, or this equation has factors whose sum is equal to negative 4 and whose product is equal to 4. So if I put in the figures that I want, it means I have negative 2 and negative 2 as the factors. So if I use factorization method, then it means I have the value of x equal to 2.